Hello and welcome back everyone to the channel. Today we are going to develop an object detection system using Python, OpenCV and YOLOv4 model. This process will be done step by step and I will explain the purpose and function of each part of the code as we construct the system together. By the end of this session, you will have a solid understanding of how to set up and utilize pre-trained object detection models on your own. So without wasting any time, let's get started. So we will start by creating a new project. I will name it object detection. Okay, now click on create. So a new project is created. First I will select my interpreter. Python interpreter, and I will choose my Python interpreter 3.12 and apply, and then okay. Okay, now let's create our first Python file. I will name the first Python file object detection. So this project will have two different scripts. One will be used for object detection and the second one will be used for object tracking. So first let's code our object detection. So to start, we import two essential libraries. First one is cv2, import cv2, and the second one is our numpy. So import numpy. Now our two essential libraries are imported. Now we have to define our object detection class. So I will say class object detection. Okay, so this will be the blueprint of creating objects that contain both data and functions. In our case, this class will encapsulate everything we need to detect objects in videos using the YOLOv4 model. Now after that we have to initialize the init function. So def underscore underscore init. So this will be automatically called when the object is created. So this will have two parameters. The first one is weights path, weights weights path. So now what I'm going to do is I'm gonna get this folder dn model. Inside this folder there are all the necessary files that you need. You will find everything in the description below. The git repository, I've created it, so I'll just copy it and I will go back here and I will paste it right here. Okay, now we have our dn model. I will just okay, now I have to copy the path of this YOLOv4 weights. Right click on it, copy path reference, absolute path, and paste it here. Don't forget to add the quotation marks. Okay, so now we have added our path. The second parameter is configuration path. So cfg underscore path. Here you have to give the path of this Python file. So it's a txt file, sorry. So right click, copy path reference, absolute path, and you have to paste it here. And also add r so it takes it as a path. So now we add a couple of print statements to provide a real-time feedback during the execution. So I'll write print loading object detection, and the second one will be print running OpenCV DNN with YOLOv4. Now one mistake I've done here, there should not be parentheses. Okay. Now after that we have to set some key parameters for detection. The first one will be self.nms threshold. This one will be equal to 0.4. This is the non-maximum suppression threshold, which helps in filtering out overlapping detection boxes. The second one is self.confidence threshold. This one will be equal to 0.5. This sets the confidence threshold. Any detection with confidence below this threshold will be ignored. And the last one is self.image size. This one will be equal to 608. So this defines the size of the image input that the model will process. In this case, it is set to 608 by 608 pixels, which is common size for YOLO models. Here we load the pre-trained YOLOv4 model using OpenCV's readNet function. So net is equals to cv2 dot read dot dnn dot readnet. So this will take two parameters. First one is the weights path, and the second one is the configuration path. Both of these we defined earlier. Now we optimize the model to utilize the GPU. So net dot set preferable backend. This will be cv2 dot dnn backend default, and the preferable target will be net dot set preferable backend will be cv2 dot dnn backend default, and then self dot model will be equal to cv2 dot dnn detection model, and here comes net. Okay. So here we have done one small mistake. It's not a set preferable backend. This one is set preferable target. Here we go. Next we prepare to load names of object classes that YOLOv4 model can detect. We start with an empty list self.classes. So self.classes will be equals to empty list. The second is load class name method. Load class names. So this method, which we will define shortly, will populate the list. Additionally, we generate colors, random colors for each class. So this will be self dot colors equals to np dot random dot uniform. The range will be 0 to 255, and the size will be equal to 80, 3. I have a comma here, and I have to correct the name of spellings of self. Okay. Now we configure the input parameters for the detection model. So self.model dot set input params The first argument will be size, that will be equals to self dot image size comma self dot image size, and then we have to define the scale. The scale will be equal will be 1 by 255. So we resize the input image to the dimension specified by self.image size, and we scale the pixel values by dividing it by 255. Now let's define the load class names method that we called earlier right here. Before that, let's correct the spelling mistake that I detected. Okay, now it's good. So what this method will do is it will read a text file containing the names of objects that our model can detect, such as car, person, dog, etc. So first we need to define the name of the function def load class names. The first argument will be self and the second parameter will be classes path. Now here right click on this classes.txt file, copy path, absolute path, and paste it right here. Okay, so first we need to get all the names in this classes.txt file. So let me show you first the classes.txt file. So here you can see there are a lot of names of classes written in this classes.txt file. Now we'll come back here. Now we will need to load each and every name in that classes.txt file. So for class names in file first we need to open the file. I forgot to open the file. With open class path in read mode as file object for class name in file object dot read lines. Class name will be equal to class name dot strip. So this function will remove any extra spaces in our name of class, and then self dot classes dot append class name. Now we have to assign unique color for every different class. So self dot color will be equal to np dot random dot uniform. The range will be 0 to 255, and the size will be equals to 80, 3, and it will return self dot classes. Okay, so this function is complete. Now finally we define the detect function. So def detect, same goes for this one. The first parameter will be self, and the second parameter will be frame, and this function will return self dot model dot detect frame NMS threshold. Will be equal to self dot NMS threshold, and then the confidence threshold will be equals to self dot confidence threshold. I will copy it here and paste it right here. Okay, so now our object detection script is complete. Now we have to make our object tracking script that will track the objects in our video. So before moving to our object tracking script, we have to remove some errors here. So we have done some mistakes in this code. First one is that we have defined this function load class names function in our init function, so we have to remove this indentation and move it out like this, and also the detect method like this. And the second is this right here, this should not be load class name, this should be self dot load class name. So self dot load class names. Okay, so now you can see the error is resolved. So now let's move to our object tracking script. So for object tracking, we are going to create a new Python file. So I will click on new Python file and I will name it object tracking. So we will start by importing some necessary libraries. First we will import CV2. So this library is essential for image and video processing. The second one is NumPy. Import NumPy. This library is essential for handling arrays and matrices. And then the third one is object detection class from our object detection.py that we just created. So from object detection import object detection. So next we initialize the object detection model by creating an instance of object detection class. So I will say ob is equals to object detection. Now what I'm going to do is I'm going to copy two sample videos that we're going to use to test our object tracking script. So I will go to my file explorer and I will copy these two videos. You will find these two also in the description in my GitHub repository. So I'll come here, right click and paste these. Okay, and add. Okay, next we will use a cv2.video capture to open video file name car detection. I'm using this one and I will later also will demonstrate this one. So it will be like cap is equals to cv2 dot video capture, and here we will give the name of the mp4 file. So for now I'm using car detection.mp4. Now initialize a counter variable to 0. So count is equals to 0. So this counter will keep track of the total number of objects detected all across the frame in the video. Then we will enter a while loop. While true. So this while loop will process each frame of the video, and then we have to read each frame of the video. So a comma frame name is equals to cap dot read. So the variable from a frame holds the image of the current frame, and a is a boolean value that indicates whether frame was read successfully or not. So cap read function reads the next frame of the video. So in the next step, we have to use our object detection method from our object detection class to detect object in each frame. So this will return three values: class ID, scores, and boxes. Class ID will be the list of class ID that are detected in a frame. The score will be the list of confidence score, and the last one, boxes, will be a list of bounding boxes, each defined by top left corner and size, indicating where each object is located. So we'll start by class ID, comma scores, comma boxes. This will be equals to ob dot detect frame is equals to frame. Now we have to draw the box around the detected object. So for drawing the box, we need four values: the xy coordinate of the top left corner, the width, and the height. So x, y, width, and height, this will be equal to box sorry, I have to write this in for loop. So for box in boxes, so for the xy coordinate of top left corner and the width and height for each box in boxes, what we're going to do is we're going to draw a rectangle cv2 dot rectangle frame. The first one will be the coordinates of the top left corner, which will be x, y. The second one we're going to say w plus x, comma h plus y. So what this says is we have to draw a line starting from x of length w, and a second line starting from y of length h, and after that we have to define a color. So we are going to use a greenish color, so it will be 30, 255, 156, and at the end we have to choose the thickness of the line, which will be 2. We have to do one more thing here. We have to increment 1. After the box is drawn, we have to increment 1, that one object is detected. So I'll say count is equals to count plus 1. Now our object detection is done, and we have to say cv2 dot I'm sure. We have to show our frame. We'll name it frame. We have to just give a tab right here. Okay, then a key will be equals to cv2 dot wait key. These are just basic things to run the cv2 and outside the while loop we have to write cap dot release, and in the end cv2 dot destroy all windows. Okay, so now our code is complete and it's ready to execute. So now let's test our object tracking code. Before that, I will show you the car detection clip, the original clip without the object tracking script implementing on it. So you can see this is just a normal clip. There is no kind of labels in this video. So we'll close this. Now we'll run the object tracking script. So here you can see the script has drawn a bounding box around each detected object or each car. So one thing you have noticed, this video when I have run through the object tracking script, it's working very slow. This is because I'm not using a GPU, I am running this on a CPU. If you have a good graphics card, this will work fine and this will play on a normal speed. So let's change the clip and use the other clip, and I will show you that one too before running it. Los Angeles one, you can see there are a lot more cars in this clip. So we just have to make one small change for this. We have to change the name of the video. This will be Los Angeles.mp4. Right click and run. So you can see it's just working perfect. It has detected each and every object in this clip. Again, it is working a little slow, but this issue can be addressed by using the GPU. So that's it for today's video. I hope you liked it. If you liked the video, please hit the like button, share the video, and I'll see you next time.